what we can say is that the limit is a y value as x approaches some x value. It says, as you get close to x, what's y? It would really have been a coordinate point on the graph. But we're usually only interested in the y value. Because we know what x is, that's the thing. Limit. If x gets closer and closer to the number L, if f of x gets closer and closer to the number L, as the x gets closer and closer to C from both sides of L, then L is a limit of f of x as x approaches C. We know, yeah, that makes perfect sense. Here's your notation. The limit as x approaches C of f of x equals L. That's your y value. The limit as x approaches C of f of x equals L. C is the number that we are coming in on. That's the x value of that coordinate point. And L is the y value. So that's why whenever we are going to be doing a limit, and this is the problem from the first page, how do I calculate a limit? I calculate a limit by hand is I plug in, in this case, x equal 1. You plug it in, plug it in. Remember, the limit ends up being a coordinate point on that graph. What's the y value? Well, if I plug it in, then I can say the limit as x approaches 1, in this case of f of x, hopefully is 2 times 1 squared plus 3 times 1 minus 3. And yeah, we're at 1. Which is 2 times 1 squared, which is 2, plus 3 times 1, which is 3, minus 3. So the limit is 2. What we say this is? This was the y value. Well, if I go back to my graph, that's this guy. There's a graph of that function. As x approaches 1, y approaches 2. Plug it in, plug it in. It's that stinking coordinate point. It's the y component of that coordinate point. Here's the other one. This is the one that's fun, not. Well, we've got x approaching 1. First thing I do is I plug it in. Because if I get a number out, that's the y component of that coordinate point. That's the limit. So I'm going to get 1 squared plus 2 times 1 minus 3 all over 1 squared minus 1, which is 0 over 0. And 0 over 0 is what? No.
Oh, error.
It's error, but what we call it? Indeterminate. Form. Now, what that really says is this. I don't know. Zero over 0, what is it? I don't know. Now, how can I find out? 0 over 0 will scream at this point in time one word. Algebra. And I'm going to reach into my toolbox and say, from college algebra, we have a tool. And the tool we have in algebra is that when I put a number in a function or in a polynomial, like x squared plus 2x minus 3, and I put that number in and I get 0, what does that mean? If I put a number in and get 0, what does that mean? How much we forget. If I take 1 squared plus 2 times 1 minus 3, and I get 0. This means x equal 1 is a intercept. And it's an x-intercept.
Because y is 0.
Yeah. And it's more than that. X equal 1 is a y-intercept. It is a 0. So, if x equal 1 is a 0, then from the factor theorem in college algebra, x minus 1 is a factor. Right? If x equal 1 is a 0, then x minus 1 has to be a factor.
It's like x plus 1, x minus 1.
Yeah. And notice the same thing happens in this denominator. X equal 1 created a denominator of 0, so that means that x minus 1 is a factor of the denominator. So the algebra that you're going to use in this instance, I am going to factor and reduce f of x so that x squared plus 2x minus 3 over x squared minus 1 is x minus 1 times x plus 3 over x minus 1 times x plus 1. The x minus 1's reduce out. So that now I'm going to instead look at the limit as x approaches 1 of x plus 3 over x plus 1. Now, does that have a limit?
Yes.
Yeah. This is 1 plus 3 over 1 plus 1, which is 4 halves, or 2. Plug it in, plug it in. If you get 0 divided by 0, that means you need to use algebra on it. Once you used algebra on it and you get rid of the offending factor, you try again. Now, we have a picture of this guy, and I'll bring this back. That's what this was. Here it is. I got 0 over 0 when x equaled 1. Notice what it created. That was the hole in the graph. I have a limit, and we saw it previously. The limit is 2. Because of all intents and purposes, the two antennas fill each other's electrons. But that's a graph of that problem. And you can see the limit was indeed 2. So we can say that the limit is a y value at a desired x value, if it exists. When you have a 0 over 0 form, what I say to myself is, I don't know whether it exists or not. It could exist, it may not exist. It just says, I need to do something more to see. Yes?
So because when you plugged in 1, it gave you that 0 over 0, then that's when you go into factor?
That's when I go into algebra.
Which is factoring.
Not always.
Oh. Well,
Yes,
in that particular
yeah.
case, you would factor.
In this particular case, I would factor.
Okay, and then once you factor, once you're done factoring.
Then you try again.
And then if it gave you 0 over 0 again.
Then I'd have to use algebra on it one more time.
Okay.
I keep going until I get something
You get a
definitive.
number.
Till I get a number or I get a number divided by 0,
Which is undetermined.
which is undefined. Yeah.
The number that we put into the equation is told to us underneath the limit in front of the
Yes, the one I plug in is that x value, yeah.
TX.
Mm-hmm.
Okay.
That says at that x value, what's that y value?